Hello, my fellow YouTubers. This is Roy back again. So, one of my coils had been grounded out. So I guess what happened is that the sharp edge, like right here, must have grounded out to the magnetic wire, and it short-circuited the coil. So I had some issues trying to figure out stuff. Why wasn't I getting the voltage I was expecting? So in the midst of all that, I did some meditating on it, and I believe that it came to me. So what I have set up right here on this circuit board is a tank circuit, and here's the L1. I set this up as a bifilar, and this was part of why I think that we're going to be pushing through this pretty good. Obviously this is too much wire. This is 300 turns of 16 and 300 turns of 20 gauge wire. But this experiment is something that it's going to bring the Tesla knowledge out of me, because if you look at the Slayer, it basically is running off of switching the transistor on and off, and that's done first by a trigger, and the trigger here is the 20 gauge wire, and the between the base and the emitter would be the trigger, and between the I guess straight through the collector would be the 16 gauge wire, and that'll open up and make the connection, and it'll make a connection to a car battery. And this has a little Bendini slash stuff in it too as well, because he has his circuitry that he calls the school circuit, and he's not using capacitors. He's not a tank circuit, he's just using the back EMF, which right here I'm going to do an experiment and show you how strong the back EMF is on here. Now we're hitting this with 24 volts, okay? And this is going to be the prime mover, which will be the thick wire. So we're going to go ahead and touch the thick wire a couple times and watch the volts build up on the voltmeter, and then we'll put a load on it. So let's see, why isn't aren't we registering? Always something. Alright, a loose wire. It's a mess here, I apologize, but I'm excited because now I got good direction. So voltmeter up to 30 volts, it climbs. So this gives me perfect opportunity to design the coil as a bifilar, using one end, like Tesla would call it, a tickler. And Tesla was the one who was using the back EMF to trigger his capacitor bank on his Tesla coil. So bringing that here We'll call it a slash Bendini slash Tesla slash Ed Leedskalnin, and now slash Roy, because I'm bringing in the tank circuit as well that will collect this back EMF. Now, the back EMF, they call it a negative charge, and nobody pays attention to the negative charge. They focus on the positive charge, which would be what would be driving the wheel. Now, every time this wheel would go by this core here, what it's going to do is going to put current, small current, into the transistor. It's going to open up the gate on the transistor, which the primary mover will be activated, and at that moment, that's where the wheel will be pulled towards the core. When it gets up towards the core, it'll go ahead and deactivate, shut the gate, because there's no power into the back, the tickler wire, and and it'll repeat the process. With doing so, we'll go ahead and get into putting loads on it, and we'll go ahead and do the Bendini experiment through it as well, to where we're going out of one battery and charging another, connecting the positive and negative on the two batteries together, and that back EMF will go through the through the battery, and the first battery will be the pickup battery, the charging battery, and we'll fill up those batteries. I got all these batteries over here. We'll start doing that. But this is the amazing thing, and the specialness about this whole setup is that we're going to minimize this coil. I think half. So right now it's at 300 turns, and I think what I'm going to do is go down to 150, so I get 2 coils per winding. And I will draw up the circuitry once I have it 100% figured out for you guys. And what'll be fascinating by is these coils will be all the way around. Each coil will have its own tank circuit, it'll have its own transistor, and it'll have its own rectifier, and it will just multiply as you go around. And I also can't wait to do some tests on, it's all about the, how much strength do we need to turn this wheel. So basically, I don't need, like Ed's magnets aren't the strongest, you know what I mean? So with this setup here, we don't need strong magnets here. We just need magnets. That's going to put this tickler into play and to turn the switch on and off. This is going to be awesome because we can see the voltage that we're getting right now. Let's go ahead and put a load on it. Now right now, I'm just turning the wheel by the primary mover, and let's connect this. Look, that's the stored energy. Look at the volts dropping. That's 4.5 watts. It takes 12 volts for that light to come on. I think it comes on lightly around 8 volts to 9 volts. And then it gets brighter and brighter. And you see we brought it up to 30 volts, and the more you keep tapping, I can set up the tank circuit in a way to where it has its own inductive. See, the tank circuit is teetering like a dipole this way, is how I'm looking at it. The coil is dipoling itself. Start from the wheel. The wheel is dipoling. In a horizontal way. The coil is dipoling this way, so it's turning vertically. This is horizontal, this is vertically, sort of like gears meshing together, if you want to look at it that way. And then coming out of this coil on the back EMF, it's going into the tank circuit. And remember that the tank circuit, the way it works with the coil, in relationship to the coil, only one of them it has a magnetic field. When one of them surrenders and doesn't have its strong field anymore, it holds on to it as long as it can, and then it has to release it. You get the snapback. So this is going to be interesting stuff to test on. So right here, let's go ahead and get this wheel pulsing a little bit. Of course, I can't pulse it as good, but you can see that the transistor is going to have no problem. And the key thing is, I don't even have to use the point system. That's now it's state of the art. So look, I leave it put on, right, and then you can see the load dropped. And then the back EMF kicked the light on. So then when you constantly cool stuff. Leave your comments, guys. Happy Mother's Day to everybody. Happy Parenting Day as well. You mothers and fathers and mothers. Look at the voltage dropping down. This wheel is going to be turning on command. We'll on this circuitry here, we'll put a potentiometer in here as a resistor. There'll be a couple resistors actually. Especially there'll be 2 resistors for the transistor, and then there'll be resistor as a potentiometer for the current. So we'll be able to control the speed of the wheel, number 1. Number 2 is all of these coils share the load of turning the wheel. So we're going to look and see how much voltage, and then how much current, how many watts we're using and to turn the wheel. And I believe it'd be minimal, and we'll look at conservation from there, how to get it down even more. And can't wait to get this thing set up. Beautiful. Finally, directions here. I'll start drawing out the circuit, because it's a combination of little John Bendini, all of Ed Leedskalnin, because all the parts on the wall is all this, and he was the first one in there. He probably learned how to make the electronic switch by Tesla, because Tesla was already had the tickler wire. If you look on the Wardenclyffe patent, you'll see that there's a primary and then a secondary, and a secondary A and secondary B. And secondary A, I believe, was just another thing of wire that was wound along with the primary. So the primary was a bifilar, and that's pretty important on the Tesla world to know that you don't need the transistor. You could have your switch right there. All right, guys. Have a good day. Peace out.